Puppetry, bringing waves to life. In this unit, students will use puppetry to bring inanimate objects to life and express their new knowledge of waves. Students will relate artistic ideas and works with societal, cultural, or historical contexts to deepen understanding. Students will make and discuss group decisions and identify responsibilities to present a drama or theater work to peers. Students will also plan and conduct investigations to provide evidence that vibrating materials can make sound and that sound can make materials vibrate. Students will develop a model to describe that light reflecting from objects and entering the eye allows objects to be seen.
So we picked a science lesson specifically on waves, wavelengths, and light. Today we're gonna start talking a little bit about waves. But most waves, the waves we're gonna be dealing with, light waves, they move sort of like this. Okay, let me see y'all do it. Okay, that's cool, right? And then John jumped in with the art.
What are we holding in this hand? Science! What are we holding in this hand? And what are we doing with those things? Good. That's what we're gonna do over the course of this week. We are gonna combine scientific learning with theatrical technique. The goal with that day was just to be like, what is a puppet? And to let them just take something basic and just get comfortable with the idea that like this is the thing that performs in this context, not the student. What if I told you that this pen could be an actor? So if you took this pen and you made up its character traits, its voice, how it moves and how it behaves, this would no longer be a pen. It would be called a what? Yes?
Puppet.
A puppet.
So on day one, in terms of content, I introduced the vocabulary words like the wavelength, the spectrum, the different types of waves. Waves exist on this thing called the spectrum. I'm gonna say it, you say it, spectrum.
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 The way these work is these are slower and then they move faster. We start over here with the biggest radio wave. From there we go to microwave, which I think most of us probably have in our kitchens. Then infrared. Then we have visible light. Ultraviolet, then we have X-ray, which y'all probably know what that is. Hopefully you never had it. And then finally, it's the gamma rays.
And then my job is to, to come in and just find some other physical and performative way because they have a physical connection to the concept. What do you notice about the difference between the radio waves on one end and the gamma rays on the other end?
The radio rays are bigger than the gamma rays.
Right, which means they take up more space, which means they move slower because they're looser. The gamma rays are tiny and they move faster because they're tight packed. Can everybody please walk around the room like a radio wave? With this particular lesson, where it's very vocab and definition heavy, it's a really good place for the art to engage in small exercises that help the students deepen their connection with all the things they have to remember. When everybody say radio waves like you're a radio wave. Radio waves. Good, now freeze. Move around the room like you're a gamma ray. So you're gonna be tight and fast. Ready? Go. And everybody say gamma rays. Gamma rays. Gamma rays.
And then day two introduced the idea of the convex and the concave lens. When we talk about the eye, we talk about our lens of our eye. And the type of lens that we have is called convex. I'm gonna say, you say it, convex lens.
Convex.
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 There's a special word for bending of light, and that fancy schmancy bending of light word, that is called refraction. And then the theater game for that, we talked about, it was the pinball game.
This is a course of water, okay? So in between each table is a refractive surface. Show me how a visible light ray moves in place. Here we go. And then I refract, whoop. And then I refract. You gotta refract just like I do. Ooh, careful. So we talked about the ways that pinballs move and had everybody bouncing off the space to help them understand the angles and the way that light moves. Oh, and I'm back where I started and I land at the focal point right here.
So day three then was the laws of reflection and different surfaces. There are 3 different types of surfaces that we're gonna learn about today, and those types of surfaces are called transparent surfaces, translucent surfaces, and opaque surfaces.
We did the traditional theater mirror game, right? 2 students stand across from each other and they are each other's mirror. So they had to interpret how that mirror would behave if it was opaque, if it was translucent, if it was transparent. See how I'm moving just behind her a little bit? Because the light is going a little bit through the mirror, and so a little bit of reflection is being lost. Mostly day 4 was committed to creating these paper cutout puppets. Kids basically each invented their own puppet. They're drawing it, they're designing it, they're gluing it to a popsicle stick. Is this a puppet yet?
No!
What do I need to do to make this a puppet?
Give it a mouth.
Give it a mouth. Make it talk. Hello, Joe. No, hello there, Sally. How are you? Oh, I'm fine. So each group of children that had created their paper puppets was given this frame, and the frame was a quiz show. So one puppet is going to be the quiz master, the other puppets in the group are going to be the contestants, and the questions are going to focus around one of the 3 topics that we learned: waves, refraction, and reflection. We let each group say, I want to do this topic. So then they came up with their group. If their group chose waves, they had to come up with 3 to 4 questions about waves to be asked by the host to the contestants.
We did not give them any mandatory questions. You must ask this, you must say this. Just it had to relate to the topic that they had chosen.
I think that more is learned when the students of building something on their own as opposed to being handed scripts and being like, this is exactly what you say, this is exactly what you do. Day 5, they had some time to review what they'd created the day before. And this was always interesting because they say, oh, we don't remember, we didn't write it down. But they surprise themselves always with how much they actually remember.
So what's something in here that might be transparent? Athen?
The window.
Yeah, the window, good.
And then we took a desk and we put it up front. One by one, let them come up and present their little puppet quiz shows.
Hello and welcome to Answer Questions or Lose Money. First question, what is transparent? Yes, Scott? Transparent is when all light goes through.
The results were pretty funny. And you know, they're 9, 10 years old, so of course they're gonna be goofy.
We'll be right back after this commercial.
Yeah, they were just given space to goof, to play, and to create.
What does light reflect off?
The artistic creativity around creating a puppet quiz show makes them stop thinking about, ugh, what's the thing I have to know? And they start investing in some art, and that allows them to just kind of trust that they know the information.
Woo-hoo!